Welcome to Keys Consumer Math and Personal Finance, Section 1.4, Operations with Integers. Actually, we're going to do operations with all kinds of numbers, and we're going to start by reviewing the number system. The first set of numbers that you learned when you were a child were the numbers that you learned to count with. 1, 2, 3, 4. Those are called the natural numbers or the counting numbers. They begin with the number 1 and they go to infinity. The next set of numbers are all the natural numbers plus 0. Those are called the whole numbers. Whole means complete or all of it. There's no partial numbers in there. And I like to also think of it as because it starts with the number 0 and 0 has a hole in it. Those are the whole numbers, even though I know that's a homophone. The next set of numbers are all of the whole numbers and their opposites, and those are called the integers. And what I mean by opposites are their negatives. So the negative of 1 would be negative 1. The opposite of 2 would be negative 2, and so forth. Integers are whole numbers and their opposites. They're all still complete numbers. Also, something to keep in mind that we're going to review a little bit later is a whole number, an integer added to its opposite they're called additive inverses, and if you add them together, you're going to get 0, like 1 plus negative 1 is 0. 2 plus negative 2 is 0. 3 plus negative 3 is 0, and so forth. The next set of numbers we're going to talk about are all of the numbers that are in between the integers. They include the integers plus all the ones in between, and those are called rational numbers. And we talked about those before. So I've got the number line here showing some of the integers, and then we're going to add all the numbers in between. Now I cannot write them all because they're infinite. So I just showed you a yellow line to say that includes all the numbers in between the integers. So that would be like a half, or 2 2/3, or negative 3 3/4, or negative 4.75, which is negative 4 3/4. But something to keep in mind, a rational number has to be able to be written as a fraction. It can be a fraction or a decimal, but if it's a decimal, it has to be it has to be a repeating or terminating decimal, because those are the only kind that can be written as fractions. Rational numbers, as we learned previously, are fractions. So they're all the parts of numbers that go in between the whole numbers and the integers. But integers are also rational numbers, because you can write 1 as 1 over 1, or you can write 2 as 2 over 1. You can write any of the integers as fractions. Here is another way to think of the number system. Instead of showing you sets, I can show them to you as a Venn diagram. You can start with the natural numbers, the counting numbers. Of course, I can't fit all of them in there, but I put some of them in there just to show a sample. The next set includes all of those numbers plus 0. Those are the whole numbers. The next set includes all of the whole numbers plus their opposites. Those would be the integers. So the integers are everything in blue, red, and green. The next set of numbers would be the rational numbers. Those are all the numbers that are in between the integers plus the integers. Those are not the only kinds of numbers, however. There are also irrational numbers. Those numbers are also in between integers, but they're not rational. They're the numbers that you cannot write as terminating or repeating decimals. For example, pi. It is non-terminating, non-repeating if you were to write it as a decimal. E is also a non-terminating, non-repeating number, and so is the square root of 2, positive or negative, or the square root of 3, or the square root of 5. Anything that you cannot write as a fraction, but it is still a part of a number, is called an irrational number. The rational numbers and the irrational numbers added together make up the real number system. And then, of course, there are also imaginary numbers, and together the real numbers plus the imaginary numbers make up the complex number system. But we will not be dealing with that in this class. Now that we've reviewed the number system and the numbers we will be using in this class, I'd like to spend a little bit more time talking about opposites or additive inverses. If you will recall, an opposite of a number is simply its negative. So if I started with a positive 5, its opposite would be negative 5. If I started with negative 7, its opposite would be the negative of negative 7, which in fact is positive 7. Integers are not the only numbers that have opposites. Rational numbers do too. So the opposite of negative 1/2 would be positive 1/2. Or the opposite of 0.63 would be negative 0.63. The thing you need to remember about opposites is that when you add them together, they equal 0. So a 5 plus a negative 5 is equal to 0. They cancel each other out. A negative 7 plus a positive 7 equals 0. They also cancel each other out. A negative 1/2 plus a positive 1/2 is equal to 0. And a 6.63 plus negative 0.63 equals 0. Additive inverses are numbers that you add together and they get 0. They're also called opposites. Another important concept that we need to review before we can perform operations on integers is absolute value. Absolute value is simply the distance a number is away from 0 on a number line, like I have up here in the top right corner. So 1 is 1 unit away from 0, while negative 1 is also 1 unit away from 0. Absolute value, by definition, is if a number is greater than or equal to 0, its absolute value is that number. Or if a number is less than 0, then its absolute value is the opposite of that number. This works out that every absolute value comes out as a positive number. For example, 7. 7 is greater than 0, right? So the absolute value of 7 is that number 7. But negative 5, that's less than 0. It's 5 units away from the 0 on the number line, so you know it has to be 5. But how does this work? Well, negative 5 is less than 0. Therefore, its absolute value is the opposite of negative 5. And the opposite of negative 5 is positive 5. So anytime you take the absolute value of a number, you are taking the positive. It is a distance, not a direction, from 0. Both absolute value and additive inverses are key concepts in the operations of numbers. Operations on numbers are simply adding, subtracting, multiplying, and dividing. And we're going to start by reviewing adding. Now, when you add two numbers with the same sign, you are simply moving in the same direction on the number line. So for example, if I were to add the number 3, positive 3, plus the positive 1, I would simply start at 0. I would move 3 units to the right because right is positive. And then I would move 1 more unit to the right, which is 4. So 3 plus 1 is 4. I'm going in the same direction. But what if I wanted to add a negative 3 to a negative 1? Well, I would start at 0, and I would move 3 in the negative direction because that was a negative 3. And then I would move 1 more negative in that direction, which would be a negative 4. So negative 3 plus negative 1 is negative 4. Another way to think of it is that you're adding their absolute values and keeping that sign. Or I should say, but keeping that sign. So the absolute value of 3 plus the absolute value of 1 is 4, and you keep the sign of positive 4. Or the absolute value of negative 3 plus the absolute value of negative 1 is 3 plus 1, which is 4. But then you go back and take the sign of negative because they're both negative. Now, when you add numbers with opposite signs, you're going to be going in opposite directions on the number line. Therefore, you're going to actually have to subtract because you're going different directions. For example, positive 3 plus negative 1. I start out from 0 and I move in the positive direction 3 units. So that gives me a positive 3. But then I'm adding a negative 1 to it. Negatives go left, so I'm going to move to the negative 1, or move to the left 1 unit, or move negative 1 to get to 2. So positive 3 plus a negative 1 actually equals a positive 2. Let's try this again with two separate numbers. Let's try a negative 3 plus a positive 1. So I would come up here to the number line, and I would start at 0, and I would go left 3 units, because negative 3 means to go left. But then I'm going to add 1. So I'm going to add a positive 1. I go back in the positive direction, or the right, and I would end up being here at negative 2. So when I add negative 3 to positive 1, I get negative 2. So when you are adding numbers with opposite signs, you are essentially subtracting their absolute values and then keeping the sign of the larger absolute value. So in the case of this problem here, I would take the absolute value of 3, which is 3. I would subtract the absolute value of 1, which is 1, and 3 minus 1 is 2. But because 3 is further away from 0 than 1 is, and it's going in the negative direction, I'm going to keep that sign, so that would be a negative 2. Negative 3 plus 1 is negative 2. But in this case, the absolute value of positive 3 is 3, the absolute value of negative 1 is 1, 3 minus 1 is 2, and because this positive 3 is further away from 0 in the positive direction, I'm going to keep that sign. So positive 3 plus negative 1 is positive 2. Algebraic subtraction is simply adding the opposite. For example, 3 minus 2 is really the same thing as saying 3 plus a negative 2. And then you would just follow the rules for addition. They're opposite signs, so you subtract, and you keep the sign of the larger, which make that 1. Or in this case, 6 minus 9 is really the same thing as saying 6 plus a negative 9. Signs are opposite, so you subtract and keep the sign of the larger absolute value. So 9 minus 6 is 3. Because 9 has a larger absolute value, it would be a negative 3. Or in this case, negative 5 plus a negative 1 is equal to, the signs are the same, so you would add them and keep that sign. 5 plus 1 is 6. They're both in the same direction, so you're going in the same direction on the number line, so the answer would be negative 6. So subtraction is simply adding the opposite of this number that you're subtracting. The sign rules for multiplication and division are the same, but two things to keep in mind. Don't forget that addition is simply fast adding, and division, in division you can never divide by 0. A denominator can never be 0. But other than that, the sign rules are the same. In other words, if you multiply a positive times a positive, or divide a positive divided by a negative positive, you're going to get a positive. Multiply a positive times a negative, or divide a positive with a negative, either one, you're going to get a negative. Or if you multiply a negative times a negative, or divide a negative by a negative, you're going to get a positive number. The negatives cancel each other out. So if we're thinking about more than 2, like 3 negatives, a negative times a negative times a negative, well, the negative times negative would become a positive, and then the positive times a negative would end up being a negative. Or you could say a negative times a negative is a positive here, and a negative times a negative is a positive here, and a positive end up being a positive. The same thing works for division. A negative number divided by a negative number divided by another negative number is going to end up being a negative number. Whereas a negative divided by a negative divided by a negative divided by a negative again, these two would end up being positive, these two would end up being positive, so the whole thing would end up being positive. If you've got an odd number of negatives that you're multiplying or dividing, the answer is going to be negative. If you have an even number of negatives that you're multiplying or dividing, the answer is going to be positive. You will need to come back to part 2 of this section to learn about order of operations and to practice some examples with me.